I am recording now. So this is sort of where we're at for the beginning. So that being said, today what we're going to talk about is simplifying and distributing. Now, yesterday, it was all combined like terms. So we did a pretty good job of sort of figuring out if things were like terms. And then for some of the things, we also tried to figure out how to put them together, and that's great. So what we're going to do today is take this another step and sort of figure out how to do some of these next things. So I have somebody waiting to get in right now. Dr. Agarwal, it's just DA. Now, I don't know who that is. I'm going to let them in. And if this is, we'll see if I have to remove them. So we'll see who this is going to be when they come in, and I'll just have everybody do this. So I'm going to admit them.
Mr. Bechtel, I was just talking to Victor, and he's trying to get in.
Okay, so right now, I think if this is, I think this is Victor. We'll see. So let's do this. Can everybody right now go to the chat and just type your name in so we have credit of who's here and who's not, and then we should be good. It'll sort of help me out to see where we're going to be at. So if you guys would write your name in the chat, that would be lovely, and then I will get started with what we're doing for our notes today. And I am recording right now. Okay, so this is what we've got. All right. Yes, and that's Victor. Hello, Victor. It's good to see you.
All right.
Yes. So hey, we're getting everybody here. This is great. Okay, so simplifying, distributing. What I want to do first is to talk about this word for a second, because a lot of times in algebra, you'll get directions that get repeated a lot. And one of the ones that happens a lot is the idea of simplify. Okay, and so they'll say, simplify this expression, simplify this, simplify that. And what I want to make sure you understand is when we talk about the word simplify, it means to make less complicated, to make more simple. And that's fine, but it's hard when you're talking about math to understand what that means. And so I want to make sure that when we say simplify, and in this case, simplify an expression is what we're going to be doing this week. When we say to simplify an expression, it means to kind of go through a couple quick things. One of them, the first thing that you want to look for, and this is something every time you're going to look for it, is you want to see first, can you combine like terms, okay? And we talked about this yesterday when we want to combine like terms, but what I would like, if I'm looking for like terms, can one of you guys remind me what are the things that I'm looking for if I want to see if something has like terms? There's two things we look for. Do you guys remember what those are? And you can either write it in the chat or you can answer it on just unmute yourself and answer this. What makes things like terms? What do we need? 2 and 7 is a very good example of like terms, but I want sort of a more general descriptions. They have to have the same this and the same this. So, same anyone? Yes, Medica, thank you. Same variables. That's one thing you look for, or in the case of your example of 2 and 7, lack of variables. If there are no variables, that's fine too. There's one other thing we want to look for. If they have the same variables, that's right, Bibiana, that's correct. Same exponents, same variables and same exponents is what we look for that. And so I'm going to give an example that's just to combine like terms. It'll have us it'll sort of review what we did yesterday. And for those of us that may not have been here, if you're watching the video, that's going to be something we can do. And so off on the side here, I'm going to write an example. And we'll just do, here we go. I'll go 5x squared plus 8x minus 7 minus 3x squared plus 2x. Okay, so this is just an example, and your instructions on a test would be simplify this expression. So the first thing that we would do,
5x when the squared plus 3x squared.
Okay, so the 5x squared and the 3x squared. Now, I'm going to ask a question, Leah. With this, is this plus or minus if I'm putting them together?
Yeah. One is positive and the other one is negative.
One is positive and the other one is negative. So when I combine them, I'm going to be making some zero pairs.
Yeah, it's gonna be 2x squared.
Very good. That's exactly right. When I put those together, I'm going to take that 5 and then minus the 3. So it's going to be a 2
Then
squared.
plus
Hold on.
2.
You're right. Hold on just a second. Wait, pause. I want to get another color so I can do this one. What is
Can
another
I?
term?
Can I?
8. Oh, yeah.
Oh,
Dale.
okay. Is 8 x
8x.
and 2x.
8x and 2x, correct. Those are also our like terms because they have the same variable. And one thing that I like that Elil did at the beginning part that you also didn't do is that we noticed that even though these have the same variable, we didn't put them together. We looked at those exponents. So, America, if I add 8x and 2x together, will there be any zero pairs?
No.
No.
Oh.
They are both positive. So
No.
how many will I have?
10
Correct. 10x.
x
And will this be a plus or a minus?
Plus
plus.
Correct. It's going to be a plus because
minus 7.
are both positive there. That's fine. And then we look at that last thing, and Elil, I think you said it, but when we're
Minus 7.
we want
Minus.
to make sure. You're right. Hold on, I want to explain it because we're recording, so that's why I want to make sure we have this. So the minus 7 there, are there like terms for that at all?
No.
No. And so with this one, it is minus 7, and I just put that here. But we want to make sure that if there isn't anything to combine it with, we still have to write it. That is one thing that people make mistakes on quizzes and tests is they'll go through and they'll combine them, and then they'll forget about this one and leave it off because they didn't combine it. But if it's here, it has to be here someplace. So if you had it here, we put it at the bottom. That's exactly right, and this would be our combining like terms. That's good. The other thing that might come up when we're simplifying expression, I'm going to put here as something to do second, okay? And for this, what I'm going to say here is distribute to eliminate parentheses. And what I want to do for a second is to make sure you guys understand P-A-R-E-T-H-E-S. No, E-S. There we go. To eliminate parentheses. It's hard for me to get my spelling right as I'm talking. When I say distribute, do you guys remember that from earlier? This was a couple weeks ago. Do you remember the distributive property? It's okay if you don't. If it's a yes, you can either type yes or you can say yes. If it's a no, that's okay too. Because nobody's talking or typing, I'm going to assume I'm going to have to review this, and it's fine. What I want to make sure we can talk about, this was something, I'm going to put down underneath here just a general example, and then I'm going to do one that looks like simplification. So the example that we had before is anytime you have a set of parentheses with two things inside. Let's say I have a 3 plus a 5. If I have a number on the outside here like a 2, when we did order of operations or PEMDAS was something we had called it before, we said first you add this together and then you multiply. And that's fine.
Yes.
But when we talk about the distributive property, another thing you can do is to take that number from the outside and multiply it with both. And this would be then 2 times 3 plus 2 times 5. And they call it distributing because you're giving it to everything that's there.
6 plus 10.
6 plus 10. So my final answer for this would be 16. Correct.
Yeah.
Now, normally, we don't just do this with numbers. This is not something where you would have it without any X's or Y's or anything. So when they say simplify, another example you might have, I'm going to try to get a good color here for my example. Sorry, I've got so many colored pens here. I'm trying to figure out what to do. So another example we could have is they could give you something here where they say in parentheses, they'll put 5x plus 3. And then outside of the parentheses, they'll put something out here like 4. Okay? And they'll say simplify this expression. And so with this, it's the same thing that we did here. It's just that what we have to do, because this has a variable and this does not, are these like terms? Is this a like term with this?
No.
No.
No, they're not. So I can't combine them inside here, which means to simplify, I'll have to distribute and then see what I can do. Normally what you do first, you look and see if you can combine any like terms. Then you look for parentheses, and if there's anything on the outside, you will distribute to try to eliminate what you have for those parentheses. So if I do this, I will be taking that 4 and multiplying it with both of those. So I will have 4 times 5x
20x.
plus 4 times 3. Now, Kwang, I'm hearing you. I heard you. Did you say 20x? Is that right?
Yeah.
Correct.
Yes.
4 times 5 is 20. That's 20x. What's 4 times 3?
12.
12. That's right. And now, so we've multiplied them. Are these like terms anymore?
No.
No, they're not. So I cannot combine them anymore. So with these, to eliminate parentheses, you multiply in or distribute, and then you do the math. And that is as far as we can go to get an answer for that. So we would have 20x plus 12 at the end of this. Now, most of the time with these examples, what they'll do is they'll give you some problems like these, and they'll say simplify, and it's going to be just like this, where you just have to combine like terms, or it'll be just like this, where you have to distribute. Sometimes they can combine the two of them, and we'll go through some examples. But the thing you have to remember is when you get to something like this, always check to see if they are like terms. Because as I look at this, 20x and 12, they don't have the same variables. So that means that I cannot combine them. If I can't combine them, this is as far as I can go. So I shouldn't put them together because this doesn't have an x and this one does. And so the America, you asked about the 32x, if that's a possible answer. And because they're not like terms, I can't put them together. This is as far as I can go, okay? Now, what I'd like to do, most of what I have just taught is, these are all of the rules, and I'm not gonna give you any new rules. They're just these two, combining like terms and distributing to eliminate parentheses. What tends to happen is that there will be ways that they combine these that look more confusing, but most of what I'd like to do is to give you some other examples to show, okay, this is something you may have to think about. This is something you may have to think about, so that you have some different examples and so that you can go off of that. So most of what I'm gonna do for the rest of these notes is gonna be to show you, this is something you might see, let's see what you would do, okay? But again, these two rules, this is pretty much what you need to know when you're doing this, okay? So let me give you another example for a second. I'm gonna rewrite this. And I think this example that I'm gonna give here, I'm gonna combine two things for a second. So what I'm gonna give is, I will say, here, I'll do example. We'll go 7, and then I'm gonna do parentheses, 2x minus 3, and then I'm gonna add more out here, plus 4x plus 8. So when we look at this, what makes this different than what we did before? What looks different about this one? What do you guys think? You can either do it in the chat or you can say it out loud.
What did you say?
I said, what makes this look different than my other examples?
It have the same variable.
It does have a 7. We haven't done that before. There are also numbers out, America says in the chat, and that's true. If we look, before we've either had this or we've had this. We've never had both. And so what I want to have you do is to figure out what to do with this then as we simplify it, because sometimes they'll give you more to do, and that's why I want us to look at it. Now I have a question. What are we supposed to look for first? When I had those two steps, what did we do first?
You need to multiply 7 with 2x and 3.
We would have to do that. That would be distributing. We would always look to see if there are like terms first, though. And this is what I want us to look at, because this is the place where it could be confusing. If I look at these two, That's 4x and that's 8. I know that those are not like terms because that does not have an x and this one does. Here is the one thing that can be confusing and I want to make sure we understand. I know that those two do look like terms, but this is the problem. As soon as there are parentheses here, I can't combine these until there are no parentheses left. So this and this can't go together until we get rid of parentheses. Because if I don't get rid of the parentheses, then they can't go here. This is almost like having a barrier or an obstacle that we have to get through before we can get to this. So what I have to do is do exactly what Kwong said, which is I need to multiply or distribute so that I can get to these, and then we can combine like terms, okay? So with that 7 on the outside there, Kwong, you said to multiply the 7 times the 2x and the 7 times the 3. Okay, so let's do that. If we do this here, 7 times 2x, I'm going to put this minus here, 7 times 3, so that stays. What is 7 times 2x?
14.
14x minus, what is 7 times 3?
21.
21. Okay, so we've taken care of these. Am I done? To anybody, am I done?
No.
Not. I need to bring both of those back down here because I haven't done anything with them yet. So I'm going to rewrite those, the plus the 4x and plus the 8. Now there's no parentheses. So now we combine like terms, okay? Because there's nothing in the way anymore, so I can put them together. Does 14x have a like term?
Yes.
What is it?
4x.
That's right. So 14x and 4x. When I combine them, what do I get?
18x.
18x is correct. Very good. And now, what about that negative 21? Does that have a like term?
Yeah.
Yeah.
8.
Negative 21 and the 8. Now, this is negative and this is positive. So we're going to have some 0 pairs.
Zero compare.
Combine them. What is it going to be?
14. No.
29.
In this case, because this is positive and this is negative, if I put negative 21 and 8 together,
13.
it's going to be negative, and it is 13. That's correct. Because the negative 21 and the positive 8, there are more negatives than positives, so I will have 13 left, so it's going to be negative. Now, are these two like terms?
Nope.
No. And if they're not like terms, then I can stop because it means I can't simplify anymore.
And that's the answer.
That is the answer. I always check for two things. Are there like terms? Are there parentheses? If your answer to both of those questions are no, then you can stop. It is simplified. Okay? Does that make sense to you?
Yes.
Okay. Okay.
Yes.
With this, can you guys do me a favor in the chat? Let's talk about how you feel about this right now with what we've done so far. If you feel good about this, do a plus. If you feel bad about this, do a minus. And if you feel in the middle, just put a 0. So you're going to do a plus, a minus, or a 0. Plus being good, minus being bad, 0 being plus. Kwong, you did a plus and a minus. That doesn't tell me anything.
Do a division then.
I'm just confused now. So we have pluses and exclamation marks, which means plus. I only had 2 of you vote. Come on, guys. I want to know where we are.
We're good. I'm good.
Okay. So here's what we can do, okay? I have one more thing to show you that is it's a twist that can confuse things, and I want to make sure we take a little bit of time to talk about it. But if this is something you understand, we should be good. I can do another example like this really quickly before we get to that, but I want to make sure we have enough time because there's one other thing that is important to know about. So do you guys want another example like this, or can I move on to the new thing? So either say more or new, and I will look. So Somebody's got to tell me that. More means another like that. New means go on. I'm patiently watching. You guys don't vote. I'm just going on. And then we go on. Okay, so I'm going to go on. I was waiting for you guys, and that's okay. So here's what we're going to do. The other thing that can happen is when you deal with negatives. So negative numbers and distribution. And here's the thing. Most of the time, everything we've done before, like when we had an example like this, when we multiplied, 7 is a positive number. So when I multiplied, it didn't change anything. It just, you multiplied, you were done. When we have negative numbers outside of the parentheses, it can change enough that I don't want you to be confused, okay? So here's what I want us to do first as we're looking at this. When I say negative numbers in distribution, what I mean is if I have two things in parentheses here, and on the outside here, I have some sort of negative number out here, and then inside here, I have a couple things in here. And that's sort of what I want us to talk about is what do we do if there's a negative out here? And it's actually really pretty easy, but I want to make sure you see it. So this is what I'll do. When you have a negative on the outside, this, as it comes in here, switches the signs. And this is what I mean. So let me give you an example. If I have a -2 outside of parentheses, and inside here, let's say this first thing I'm going to have a 2x, and the second thing that I have here is going to be a +4, okay? Now, let me ask, is this positive or negative? That one right there.
Positive.
It's
Positive.
Okay, what about this one? Is this one positive or negative?
Positive.
Also positive, okay. So when I distribute this -2,
Oh, I know what you mean.
and they bring them in here, it is gonna switch both of those signs because they were positive. I multiplied by a negative number, so the positive becomes negative, the positive becomes negative, okay? So what this means is that it'll look like this. This will be -2 times 2x, and then this one here will be -2 times 4. Now, what is this? -2.
Multiplication.
It's multiplication. And so 2 times 2 gives me what answer?
0.
Alright.
Oh no, I mean 4.
2 times 2 is 4. And because we have a negative, it will be a -4x. So that positive became a negative, okay?
Yeah.
What do we get when we do the -2 times 4?
8.
8. And because it's a negative times a positive, we will get a negative. So that positive became a negative. If you notice, both of those positive, both became negatives. And then I'll ask this question.
Why
Are
they
those like
become
terms?
negative? Why they become negative?
They become negative because one of the rules that you have when you multiply anything times a negative number, it changes the sign before. So we started with a negative, we multiplied by a positive. A negative times a positive is a negative. So I can show you those rules over on the side here. If I have a negative times a positive, I will get a negative number. If I have a positive times a negative, I'll get a negative number. If I have a negative times a negative, it's going to switch the sign and give me a positive number. So
Oh, I get it.
you've involved with that, it's fine. The other one that we already know, if I have 2 positives, it'll be a positive. That's just regular multiplication.
Yeah.
Okay. So that's the reason why they're both negative. Now, are those like terms?
No.
Nope. So at this point, there are no more like terms and no parentheses. I'm finished. Okay. Now, that's one of those things that can be a little confusing. And so I want to make sure that I can go through another example with you, but that's sort of the way that we start to think a little bit about what happens when you take a negative number from the outside and distribute it inside. Now, I'm looking at my time a little bit. We've still got about 2 minutes, so I've probably got time for 2 more examples to show you what you've got to do with this. I don't think they should be too hard though. So I want to show you another. If I have a negative outside and let's say inside here, I've got 5x minus 2y minus 3, okay? I want to show you something really quickly. I don't have a number there, but there is a negative outside this set of
That's
parentheses.
why.
That's what I have to put there. It's like there is an imaginary 1 on the outside. So I'm still distributing that number to all of the things. So what I try to think about is, what are the signs here? This is a positive, this is a negative, this is a negative. So when I'm done, if I take this negative and I distribute it to all of them, it's going to change the signs. So this one will become a negative, this one will become a positive, and this one will become a positive, okay? So here's what I want to think about. When I put those together, if I multiply by 1, does that change that number at all?
No.
No.
So all I have to think about now is when I multiply this, negative 1 times 5x, negative 1 times negative 2y, and negative 1 times negative 3, the numbers aren't going to change. The only thing we're going to change is the sign. So this
Yes.
was a positive, it becomes a negative 5x. This was a negative, it's going to become a positive 2y. This was a negative, it's going to become a positive 3. And that's all we had to do to change that. So here I have these 3 numbers, and this is the end of it because I don't have any like terms. So that is simplified. Now, I do want you to listen because we're coming close to the end here. Your assignment on Delta Math that has some things with distributing and negative, there are going to be a lot of examples like this, or they could be things where we have to combine like terms at the end. I want you to do your best and try those. And they shouldn't be too confusing, but do make sure that you're checking to see what happens if you have a negative on the outside to bring them in. If there's anything that comes up as you're trying these or you're trying the assessment that we have at the end of the week, you can ask, you can send an email and ask, say, I'm having problems with number this. Can you explain this? Or you can even write the problem out and we can talk a little bit about it. I just want to make sure that you've had a good chance to sort of try what we're doing to see what's going to happen. So we've come to the end of our time. I'm going to stop sharing and ask if anybody has any questions about anything at this point before I send you off to your other class. Is there anything that you have as questions with what you have to do, with what we have coming on here? Is there anything right now that I can clear up before you?
So my grades is gonna be changed tomorrow?
I know you're worried about this. Before the end of today, your grade should be changed. Okay? Okay.
So the homework is gonna be in Delta Math?
The Delta Math homework is the only homework we have for this week. And then in Google Classroom, there will be I think it's called your week 4 assessment, I think is what it says in there. It should be there now.
Thank you.
You're welcome. And if nobody has any other questions, you guys can go and have a lovely weekend.
You too. Bye.
Thank you. Bye.
Bye-bye.
Bye-bye. Bye, Mr. Gregoire.
Adios. Bye-bye.
Okay.
All right, Mr. Bechtel. Have a good weekend, you too.
You as well.
Okay.
Bye-bye.
Bye-bye.